Okay, so I was just going to continue this week on object-oriented programming. We'll pick up right where we left off in our demonstration of that account, annuity, savings account demonstration. But before we do, I wanted to draw your attention to the Gantt chart. Again, with this section, I don't think that there's any problem. If you've got your own way of organizing everything, great. But over the next 3 days, you're going to want to have a working implementation, not a completely 100% bug-free implementation, but an implementation by Wednesday to give yourself those 2 days to actually test, debug, and get some feedback if you want to. Now, if you turned in a design document that was that had a sufficient amount of details that we can give you meaningful feedback, then you're probably going to be okay on design as long as you incorporate that feedback. That feedback should be due by Tuesday. I've set a due date of Tuesday on that, and we'll open those up on Tuesday, 5 p.m. from the LAs. But otherwise, make sure that you're reading that. If you didn't give enough details in your design documents that we can provide meaningful feedback, then what I would do is I would suggest that you get a working version done by Wednesday so that you can go to an LA and get some feedback in person based on your actual implementation instead of your design document. All right? Any questions on any of that? All right, we're good. All right, so to continue from last time, remember that we were looking at inheritance. All right, we'll look at that, the rest of the stuff here in a second. At its base, what we've got is an abstract idea of an animal, and then a dog is an animal, a cat is an animal. Anytime you put yourself into this kind of hierarchy, you are using inheritance. Right? Now, an animal is not necessarily a dog, it's not necessarily a cat, but a dog is a cat, a dog is an animal. That's the key word there, is a. When you put something into a hierarchy, this thing is a, whatever the thing up above it is. Right? Now, is a dog a cat or is a cat a dog? No, you can't force those to become each other. A dog is a cat. Sometimes you can go ahead and force an animal to become a dog, but not if it's a cat. Okay? So to continue with what we were looking at last time, what we did is we successfully got rid of redundancy here by putting that, what would we put into the account here? Account number and owner up into the superclass. Now, by the way, what does this look like at this point? Let's go over here and highlight account, annuity, and savings. It looks something like this if I auto-generate this using Plant UML, which is a tool that you'll be exposed to either in your lab this week or certainly on your homework. Because Plant UML is the one that we suggest that you use, right? Why? Because you click on something and it automatically generates this. Right-click, export, and you're done with your design documents figures, right? So it's a very, very nice tool. By the way, some other people were, for your design document, we were only expecting a handwritten sketch or a whiteboard and then you take a photo of it or something like that. Some people went the extra mile and used a tool like, I don't know what they used, but the one that I would suggest that you use if you are going to sketch things out using a tool is app.diagrams.net. It allows you to do things with UML. For example, you can go ahead and put in an object over here. You can go ahead and pre-populate it with objects, fields, and or methods, right? And then you can start editing that and drawing lines between them if you want. This is a meaningless line, but you can go ahead and connect it and do whatever. You got to get used to it first. I guess I don't want that. What I want is something that looks like this. There we go. And then I can go ahead and connect that thing, come on, that thing to that thing. There we go, it just snaps to it. And I've got a nice looking diagram here. Eventually it looks something like this. There's that animal, there's that dog, there's that cat. The extends relationship is defined by those arrows. We've got superclasses and subclasses. I'm hiding below there because we're gonna get that out later. Right? But otherwise, Plant UML, the instructions for doing that are available on GitHub. I'm putting both of these tips, both of these links here in the notes so that when the notes get published later today, you'll have direct links to them. Right? But otherwise, Plant UML, I've got 4-step instructions. All you have to do is install it in Eclipse, and all you have to do is highlight a class, and you're done. Right? So this is the landscape so far. Remember that we had this get value function. Get value, get value, get value. What did we end up? How did we end up doing that over here in the account? We made it into an abstract class because it was a pure it was not a pure abstraction, but I didn't want an account to be created. I want to be able to create savings accounts and annuities, but I don't want you just willy-nilly creating an account, right? So remember that we tried to create an account. We prevented that by making it into an abstract class. That also helped us with the design on get value. A savings account, its value is simply just the balance that you've got stored in that savings account. An annuity, the value there is the monthly payments times, in fact, we can look at it. It's the monthly payments times the number of years times 12 because 12 months in a year. That's the value of an annuity. That allows me to iterate over and get the value of all of them, total it up, and print it out. It also prevents me from creating this abstract idea. You see this all over the place. Let's take a look at an example in an actual example in the Java Collections library. This is an abridged version. We'll take a look at what the actual landscape looks like here in a second. But you've got this inheritance, right? You've been using array lists and hash sets. Well, what is an array list? An array list is a list. Well, what is a list? A list is a collection, right? So this inheritance hierarchy says that all four of these things, if it's a hash set, a tree set, an array list, or a linked list, all of them are collections. They hold stuff. But now we have specialization. How does a set hold stuff? It holds it unordered and does not allow duplicates. That's specialization. What about a list? It holds stuff in an ordered manner so that you can sort it, but also it allows duplicates. Right? So different behavior here, justifying this hierarchy. If you go down one level here, okay, a list is actually just an interface here. We'll talk about that in a moment. But an array list and a linked list, they provide the same thing that a list does, that a collection does because of this inheritance, but they do it in a different manner. How do you think stuff is stored in an array list? Using an array, right? How do you think stuff is stored in a linked list? We'll look at that later, but here's how it works. It doesn't use an array, instead it uses nodes, these spheres, right? And what you do is you put one element into the sphere, but the sphere also has a reference to the next element. It's linked to another sphere that holds an element, and then that's linked to another sphere, right? And we've got these this linked nodes all together, kind of like a chain. You want to add another link to the chain at the end, fine. You want to add it at the beginning, fine. You want to break this chain apart and add a link inside, fine. You can go ahead and put it back together. That's a linked list. So it provides more specialized behavior down below. Now, just in case you think, well, that's simple, here's the actual, and in fact, I think that this is still abridged. Here's the actual hierarchy just dealing with sets and lists. Right? One thing that you don't see in here is a map, and we'll talk about that in a second. Why not? All right. Anyway, you've got these levels of abstraction. You've got your classes down here, array list, linked list. You can create those. You can use those, just like you have a savings account and an annuity account. Right? Above that, you have an abstraction, the idea that is common to all these things down here. We've got an abstract collection, abstract list, abstract set, abstract sequential list, et cetera, et cetera. Why? Because array list is not a sequential list. Right? Well, you'd have to look up the documentation why they did that. But that's not enough. What we need is a abstraction above that even. Right? This is a pure abstraction. These are called interfaces in Java and most programming languages. They do not have any variables. They do not have any methods, any implemented methods. Asterisk, they introduced default methods in a later version of Java. We will not be looking at them though, right? We're going to continue treating our interfaces as pure abstractions. Why would you want something like that? Let's look at another scenario. So this is a company, very much like the company that you'll work with in Lab 5 this week, that has employees, two different types of employees, hourly and salaried. You have to pay your employees, right, for the most part. Right? And so those are payable, right? But also, you have to pay your suppliers. If you don't pay your suppliers, then they don't supply anything. Right? But now at this particular company, we have a different type of employee that's not really an employee because we don't pay them. They're called an intern. Right? And even though they're not being treated like it, they are in fact people. Right? So we've got people and we've got employees, which are people as well. But suppliers are not people. They're companies or entities or something, right? So I've defined 3 different hierarchies here, 3 different levels to this hierarchy. But I've not locked myself into saying that everything in this hierarchy is a person, because they're not, and a supplier is not. Not everything in this hierarchy is payable, because we're not paying our interns. And by the way, life pro tip here, as computer scientists, computer engineers, software engineers, never ever even consider the idea of an unpaid internship, all right? Don't even consider an internship that's minimum wage, even in this area, right? I asked in the last session if anybody wanted to talk about their internship, but nobody wanted to, or maybe they didn't have any internships. Anybody want to humble brag not their salary, because I don't think any interns would ever have a salary. Correct me if I'm wrong. Anybody hourly? Yes. All right. Do you want to say what you got? I get 20 an hour. 20 an hour. Is this Samuels? Yeah. Okay. And where? Yeah, well, you don't have to if you don't want to. I get 17. 18, 17, 18, 20, right? That's the range that the rest of you should be going for here in Lincoln, right? You go somewhere else, you're looking even more, right? That's internships. Do not accept an hourly wage as a full paid position. I'm actually surprised that San Angels is still at 20.
Yeah, that's tech support though.
Oh, okay. What other internships do they have?
They have business analyst, which is 18 an hour.
Oh, okay.
There's a software intern, and that's 25.
25. All right, there you go, right? So never accept an unpaid internship in our area, of course. There are some other areas where they'll say that, yeah, you have to do it. Don't be in those areas then. Anyway, so by creating this abstraction, these what are called interfaces, I'm able to create this business model without having to lock myself into a hierarchy. Right? Let's come back over here and see how it works, at least syntactically. Right? Now, an account has an owner, and an annuity has an owner. So maybe there's some commonality here. Maybe I should say that every account has an owner, right? Well, that's true. We've got an owner up here. But I'm going to go ahead and create what's called an interface, this pure abstraction, new interface. And I'll call it ownable, right? Usually grammar question for the day. The owner is a noun. Own would be the verb. Ownable, the state of being able to have the possibility of it. What is that called? You can own something. That's not a gerund. Adjective? Well, yeah, but it's not just a regular adjective, because it's a verb that's been made into an adverb then, right? Adverb? No, that's like owning it fully. Fully is the adverb. I don't know. Grammar lesson for the day. I have no idea. Tell me, look that up and find out what it is. But anyway, you can define public interfaces here. Public, get owner, person, get owner. There we go. That is a pure abstraction. Do you see any variables there at all? No. Do you see any actual methods there that are implemented? No. This is a pure interface. It's a pure abstract class. All of its methods are abstract. In fact, it knows that this is going to be abstract because this is an interface, and so it was fine without me even putting that in there. Don't do that. Even if you don't need to put the keyword abstract in there, you should still do that. So that I can come over here to account and say, now we don't extend an interface, instead we implement an interface. Implements ownable. And this is perfectly fine because we've got a get an owner function already. Right? And so let's go ahead and look at the landscape now. Ownable, person, or not person, but savings and annuity. There we go. I added one level, arguably, of complexity to my hierarchy here by creating this ownable interface up here. An account implements that thing. Now, the example that I did in the last class, I still couldn't think of a better one, so we'll go ahead and go with it. What if I have a petty cash account? Or incidental? Incidentals. I'll call it incidentals, right? Here's a incidentals account. It extends an account. There we go. Incidentals. And so what is it? I'm going to create a constructor here because I have to. And then also, because it extends account, it also, incidentals, account, not all of it, account and ownable, right? Because incidentals is a subclass of account, I am forced to implement this interface right here. But it doesn't have an owner, right? Who's the owner of an incidentals account? It's the company, right? The petty cash account, all right, you go, by the way, I need cleaner for my desk because I spilled my pop all over it, right? Okay, well, go and get some. Oh, we're out. Okay, go down to Walmart and buy some and then we'll reimburse you. Petty cash or incidental account, right? There's nobody that owns that account. But I still want to be able to model that thing. By making all accounts implement that ownable interface, I've now locked myself into this hierarchy, which doesn't make sense anymore. Imagine if Java had done that with maps. Right? One thing that you don't see here is a map. Why? A map holds stuff, but does it just hold stuff like a set does in an unordered manner? Does it just hold stuff in an ordered manner? No. It holds stuff in a key value pairing. Where would a map go in this hierarchy here? I don't know, right? Well, what if we put it down here as an abstract list? Now you have to treat your map like a list. Does that sound right? No. You have to treat, another good example would be vehicle, car, bus. What if I put car instead of in that hierarchy? What if I put it in the animal hierarchy, right, for whatever reason, right? Because it has an owner as well, right? Well, now you're forcing your car to become an animal. Is it a dog? Is it a cat? No. Is a cat a dog? Is a cat a car? No. It doesn't really make sense. So by having these interfaces up here, what you can do is called mix-in typing. So mix-ins. What's an example? The ice cream place. So we plugged Sandales. We might as well plug the ice cream place. What's the ice cream place? Okay, do they have mix-ins there? I don't know. The one Cold Stone. I'm thinking of Cold Stone here. So Cold Stone. Oh, great! You got your ice cream. Now what do? They say, what do you want as a mix-in? Not a topping, but a mix-in, because they'll put it in there and they'll mix it in for you, right? In object-oriented programming, we have mix-ins. That brings up duck typing again. How do you know that this thing is a duck? I'll go ahead and mix in a quack method. I'll go ahead and mix in a waddle method. Now it's a duck. That's what the interfaces do, right? You want to mix in behavior. You want to mix in an interface to guarantee that you can treat all sets like a collection so that you can iterate over them or get an element or something like that, or add an element is better. But what about a list? If I put a list somewhere in this hierarchy here, or sorry, a map, if I put a map somewhere in this hierarchy, I would be locked in. I would not be able to do that. If I put an intern as an employee, then that forces them to not only become a person, which they are, but it also forces me to define what it means to pay an intern, right? Which means that I probably would have to hard code that to 0, which is not very good, right? Because now it opens yourself up to anomalies where, oops, somebody just goes in, the intern themselves is responsible for the payroll system, and they just go in and change one number to $1,000 instead of the 0, right? You don't want that in your design. Maybe you do, I don't know. Right? If you're designing it and it's not your money, then you do want it in your design, right? But no, you don't want to lock yourself into these hierarchies here, right? And that is a risk. So I don't want to lock myself into this hierarchy because it forces me to define an incidentals account to have an owner, right? Okay, well, let's take that away. Let's go back to account here. We won't make it so that all accounts implement owner. Instead, what we'll say, oh, well, a savings account, that has an owner. Oops, implements, ownable. Right? Do we, grammar nerds, do we have a ruling on this? No. What is it? Is it an adverb? No? All right, so savings, annuity is also implements ownable, but incidentals does no longer has to implement an ownable. Add unimplemented methods, get value. But we do have to have a value, like a balance or something, right? Now, looking at the entire landscape yet again, we've got incidentals, we've got we've got ownable, and we've got savings. Right, there we go. There's your hierarchy so far. But by making it so that I put this abstract idea of ownable into an interface, that allows me to say, okay, well, that's ownable, but that's not ownable, right? That's payable, that's not payable, that is payable. It gives you some more flexibility here, okay? And if you've got a sufficiently complex hierarchy, it really saves your neck with the design, right? If you didn't do something like this and do it well up front, then you're locking yourself into that hierarchy. A hierarchy is rigid, and later on, 5 years down the road, you want to add a new business rule that doesn't fit into this hierarchy. Guess what? All of your code breaks. Or you're doing it differently just to accommodate that new rule, right? That violates the open-close principle of object-oriented programming, of the solid principles that we'll talk at the end, right? Okay. So, questions on this so far? Otherwise, that's all I wanted to do for the demo. What we can now do is we can go back and start making observations about what we did, right? So if a class A extends a class B, then we have some terminology here, right? B is the subclass or the child class, etc., or the derived class, and A is the superclass, the parent class, or the derivable. I don't even remember what. That's why we only say parent-child. I don't remember. Derived class, derived class. I don't know. Don't worry about it. Anyway. Inheritance defines an is a relationship, right? A dog is an animal. A cat is an animal, but not the other way around, right? So let me make note of that, right? A dog is a animal, or an animal in this case, right? Animal, right? There are three types of relationships here, or three types of relations in inheritance. We have a covariant relationship, a contravariant, and a covariant relationship. Right? To do that, I'm simply just going to jump to my picture here. So in this one, I used a robin, an ostrich, and a bird instead of a dog, cat, and animal. Go ahead and just context switch out here to a robin and an ostrich, right? A robin is a bird, an ostrich is a bird, and so that is a covariant type of relationship where you take a subclass and treat it as a superclass type. That is always safe, right? So let's come back over here to the notes. A covariant, invariant, sorry. Covariant, the first one, always safe. You treat the subclass as a superclass. And again, why would you ever want to do this? Let's come back to our example that we worked through. Let's go to the demo here. By creating this hierarchy, guess what? I only have to have one list of accounts to rule them all. I can iterate over them and treat them all as accounts to get their value so that I can sum them up. Much simpler code. What would the alternative be here? What if they were not all accounts? If I didn't do something like that, I'd have to have code that looked like this. Do not write code that looks like this. If A, instance of savings, then I will force it to become a savings account. Savings SA is equal to savings of A. So that I can go A.get, or SA.get balance. Follow that logic there. What else am I going to have to do now for an annuity? Else if A is an instance of annuity, whatever, right? Then I'll have to do a typecast, right? And force it to become an annuity so that I can grab its monthly payment, its the number of terms and a number of years, and then multiply it by 12. That sounds like an annuity thing. Where does that logic belong? in the annuity class. Get balance. That sounds like a savings account thing. Where does it belong? In the savings account class. If you find yourself doing something like this, there's only one instance in your project that you should be doing something like this, and this is when you're loading them up from a file or a database. But if you find yourself doing this as a matter of course, you're doing something wrong. You are breaking encapsulation, you are violating inheritance, right? You're violating abstraction as well, because you're forcing it to become a contravariant relationship. If you take a bird and force it to become an ostrich, if it's an ostrich, that's safe. If it's a robin that you treated as a bird so that you could force it to become an ostrich, that's not safe. That's contravariant, right? So contravariant is sometimes safe, sometimes dangerous. You need to explicitly check, right? You treat a superclass as a subclass. There we go. Not something you want to get into the habit of, right? If you are doing something like this, you're probably doing something wrong. Not only that, I mean, if you come in and you introduce a new incidentals account, a stock account, another account, 5 new account types in this banking account system, right? What are you going to have to do? Else if, else if, else if, else if. Anytime you add a new account, else if, else if, else if, right? Don't do that. Right? Instead, everything should be self-contained and isolated in the class that you introduce. Now, if I take a look at this code, awesome code, because if I introduce a new incidentals account, did I have to change that at all? Incidentals I is equal to ... Put that into myaccounts.add. Do I have to change this code down here at all? Nope. Do I have to change this list at all? Nope. Right. So that's the advantage of this. One of the other advantages of doing it correctly. Invariant is where you treat never safe. You treat one class as a sibling, right? So, for example, can you force a robin to become an ostrich? It's kind of difficult. Can you force an ostrich to become a robin? Nope. Right. Oh, the other examples I've done in the past where I've introduced interface, it's worth mentioning here because some birds you eat and some birds you don't, right? So in this case, would anybody ever eat a robin? No, that's not good eating. But would you eat an ostrich? Yeah, that's good eating. That's you go down to Fuddruckers and get an ostrich burger, right? Chicken would be another bird that some people eat. And then I usually throw in as a joke an ortolan. Have you ever heard of an ortolan? It's a bird that you eat whole and raw, I think. Right? It's a French delicacy. Gross. Don't eat that. Anyway, so that's the 3 types of relationships. Covariant, always safe. Contravariant, who knows? Probably don't want to do something like that. And invariant, never safe. You never want to do something like that. Okay? So avoid, you can, but should not use the instance of keyword to check type safety. Right? Don't do it, right? Let's see, what else? Motivations, I guess. Again, motivations for inheritance. Again, code reuse, right? Reuse. Reduction of redundancy, right? Why? Because you can take common functionality and you can locate it in the superclass, and then everything inherits it. It's much cleaner hierarchy of elements, right? You can treat many types as one. This gets into something called, this is the 4th pillar, polymorphism, right? Later, right? Later, there we go. Right? You don't have to create a list for bank account, savings accounts. You don't have to create another list for incidentals. You don't have to create another list, another list, another list, another list. There's one list that you can create to rule them all, right? And then you don't have to worry about, all right, I have to add them all up here, add them all up here, add them all up there. We'll look at that in more detail when we actually look at polymorphism, right? Some other miscellaneous stuff, right? An interface is a pure abstract class. All right. Generally, it only defines methods, public interface methods. Right? You can define an abstract class to, one, prevent instantiation of instances. Right? You cannot create instances of an abstract class. And two, to avoid defining ill-defined methods. Right? Avoid being forced to. There you go. Forced to define ill-defined methods. Define ill-defined methods. There we go. All right. Again, if you've got a generic bird, how does a generic bird move? That's why I used robin and ostrich. How does an ostrich move? It runs or walks, right? Ostriches don't fly. What about a robin? Hop or fly, however you want to look at it, right? But that's specialized behaviors. All birds move. But what if I were forced to define how a generic bird moved? Ruffled? Not all birds have feathers too, right? I don't know. Is that a defining characteristic? These are called phenotypes, and it's what polymorphism is named for. But anyway, I don't have enough biology to know what's correct or not, right? Another tip here is you can use the keyword final on a class. For example, okay, so in one context, a final variable means you cannot change it, right? It's a constant. It makes it into a constant. Oops. Variable, there we go. And a final method means you cannot override it in the subclass, right? You prevent people from making changes to your behavior, to the behavior of your class, to the behavior of your class. Let's take a look. So remember over here with savings, I did want to override the get value method. If I had up here in the account method, if I had said, I don't know, I'll make this one in public final person. There we go. Now down here in the subclass, if you wanted to change it so that it was, say, public person get owner, and we'll do something weird instead. Return Chris. I'm always the owner. Here, that's new person Chris. I'm taking all of your bank accounts now. Right? The owner is always me. But guess what? I can't do that anymore. Why? Because up in the super class, in the account class, I said it's final. That's the final word. You cannot provide any more specialization than this. Right? Why would you want to do that? If you want to define something that everything should have common interface and behavior, and then prevent people from doing something. For example, what if I were allowed to change the, I don't know, capital, too lower. Right. Oh, where's too lower? Fine, case, lower, there we go. What if I were to change this method here to lowercase, and I wanted to create my own string class that said, okay, well, what I'm gonna do is I'm gonna screw around with you and make it into alt caps, right? Capital, lower, capital, lower, capital, lower, capital, lower, right? Should I be able to do that? No. So maybe you've got an argument there to make this final. It's not final for different reasons. That gets us into the third usage of it. A final class makes it so you cannot extend it. Sorry for the bad grammar there, but that's the key word. I'm gonna use it. You can't extend it. Right. For example, let's come back over here and fix my mistake and get rid of owner, right? And make it so that the account itself is a public final abstract class. And you can do that. You can't do this with an abstract class, but what's wrong? Yeah, well, let's get rid of this for a second here. That's why. All right. Now, am I able to extend this? Nope. Annuity cannot extends account because you made the entire class into a final class. Undo, 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 undo. That's not what I want. But where would you want something like that? Integer x. Integer. Right. What if I wanted to create my own integer class? One where addition now means subtraction and multiplication means modulo or something. Does that make any sense? No. It would be me screwing up somebody else's design. So they thought ahead and they said that the integer class is final, right? Because there are certain expected behaviors that anybody using Java is going to have. They're going to have an expectation that the integer class does what it should, right? That it represents integers, that plus means addition, that minus means subtraction, et cetera, right? And so what they've done is they've said, no, you cannot extend the integer class and change what an integer means because that is built into the language. So they made that class final. You cannot extend it. Go ahead and try it. Let's go ahead and collapse this. And I'm going to go ahead and create a new class, my integer. There we go. And I'm going to say extends integer. Nope. Integer is final. Now, even though it's saying that you can do that down here, it's not compiling. Right? Type my integer cannot subclass by the final class integer. It's preventing you from doing this. 3 nice uses of the final keyword. 1, to make it so that you can't change a variable. 1, to make it so that you can't change a method. 1, to make sure that you can't change a class. Right? Can't change, can't change, can't change. It's just in a different context. Right? Another note here, non-final methods are called virtual methods. Virtual methods. Do not think virtual reality. Do not think virtual as in fake. I don't know why they decided to use that terminology. They're bad at naming things. But a virtual method is a method that can be overridden and changed. The reason that they call it virtual is because the code doesn't actually exist until runtime. And what I mean by that is, let's take a look at another diagram here. Where is it? Yeah, there we go. Here's another bird diagram. All right. And suppose that you had 2 birds, one Charlie and one D. Right? Charlie is a robin and D is an ostrich. There's a common interface here, move, right? But a robin moves by flying. An ostrich moves by walking, right? I didn't make them fast. Right? This is why they're called virtual methods, because the move method doesn't actually exist until you actually create this. What happens is there is a line here. Let's call it a pointer because that's what it is. It's a reference. It's a reference to the code stored in this function right here. There is no actual move method. Instead, it's virtual. When you create this robin, it says, all right, there's a move method, but because I'm a robin, it is actually pointing over here to this fly method. When you create an ostrich, I've got this move method, but it's actually pointing to this walk method over here instead. That's why we call them virtual, because they're not actual methods, right, with an implementation. Instead, they're references to other methods that do have an implementation based on what the type is, either an ostrich or a robin. All right. Any Always Sunny fans? All right, no? Wow. It's not a generational thing. I'm not that old. Come on. Anyway, you just don't like good comedy, apparently. Or you don't want to admit it. All right, so a pure abstract class is one of those interfaces. Right? A pure abstract class in which there are no functions are defined, i.e. all functions are abstract, is on interface. Right? You use the keyword implements instead of extends. Right? And another nice thing here is you can implements, and again, bad grammar intentionally, implements, because I don't want to change the keyword here, implements more than one interface. That's another reason that you might want to use an interface instead. Let's take a look at our old employee example here. If I did put intern into a hierarchy, it could only extend one class. But if I put things into interfaces, an employee can inherit from one interface, two interfaces, or just one interface, or 5 interfaces. Or over here, let's look at linked list. It's inheriting from 4 different interfaces, or it's implementing 4 different interfaces. Right? That's another reason that you would want to use interfaces instead of classes, because Java is a single inheritance hierarchy. You can only extend one class. Right? There are languages that allow you to do that, but that's one of the pitfalls, right, to inheritance. Right? Some languages allow you to do what's called multiple inheritance. Okay? You can inherit or extend, and that's why I'm putting in quotation marks here now, because you cannot do this in Java, and thank God you cannot do this in Java. Right? There's only one language that I know of that is statically typed that you can do something like this. Right? C++. And again, nobody else has ever done it. Why? Because it's a bad idea. Right? It leads to, Java is not one of them. It's a single inheritance hierarchy. Good. Right? It is a single inheritance hierarchy. Right? You can only extends one class, not multiple. C++ does allow it, right? But it gets you into what's called the diamond problem. So what does the diamond problem look like? That's where I'm going back to my cat-dog diagram. And let's go ahead and scroll up here and show you what happens when you extend multiple classes here. Animal, dog, cat, nice and clean. What happens when, and I'll zoom in here, what happens when you extend from a dog and a cat? What is it? Cat dog? All right. Was that the cartoon, or was it dog cat? Dog. Oh, there. That's a different one. Dog Man is different. That's a comic book too, right? Is it ever going to be a cartoon? Oh, hopefully. I'll watch it with my kids. Yeah. Cat Dog. It was another older cartoon. Cat Dog. Let's find out what happens when you have a cat dog. You have this weird, freakish animal here with 2 heads, right? So weird, freakish animals do not belong in your hierarchy, right? Why? Because every animal speaks. A dog barks, a cat meows. But what does a cat dog do for it to speak? I don't know. Now, in a language like C++ that allows you to do something like this, that means that you have to take an extra step. And you have to say, when I speak, I want you to call the cat method so that I meow. Or when I speak, I want you to call the dog method so that I bark. Or when I speak, I do something completely different. Right? You're forced to not inherit from your parents, and you have to explicitly say what you do for every single one of these methods. Right? So why the extra steps? Right? Most languages don't allow you to do this. And that's, well, by the way, why is it called the diamond problem? What do I have here? A diamond shape, right? And that's why it's called the diamond problem. Right? Do you inherit from one or the other, or what? Right? It's not well defined. It's ambiguous. Right? Java avoids this by only allowing you to do one. Okay. All right. So, what is that? What is that idea? I think it's a homonym, or no? It's not a homonym. Okay. Species, phylum, genus, order. What is it? Taxonomic rank, classification. There we go. Species, genus, family, order, class, phylum, kingdom, and domain. How do you remember that? Did anybody have the mnemonic device? That's what it is. Mnemonic device. What is it? All right. Mnemonic device. Nobody ever had to memorize this stuff for taxonomy, and then you don't even remember the mnemonic device anymore. Annihilate plants and fungi that blah blah blah. It's something with king something. King George, King Philip. There we go. Mnemonic device. King Philip came over from Great Spain. Alternative. Okay, no, oh, that's the alternatives, right? So you have to remember D, I guess. It's a mnemonic device. King Philip came over from Great Spain. Alternative. Not alternative. Sorry, I keep reading that. Anyway, that's pretty deep, right? 1, 2, 3, 4, 5, 6, 7, 8. Right? If you had 8 classes deep, and not that you're going to do this, but species is down here and domain is up here. All right. What if it's too deep? Right? Up here we've got absolute generalization. Down here we've got absolute specification. Right? Concrete, abstract. What are you doing with your class hierarchy the entire time to remember what you did where? Right? You're looking up at the top and saying, okay, we've got absolute generalization here. So that's where this behavior was introduced, and then go down, go down, go down. Okay, that's where it's defined. Okay, I overwrite it there. Okay, and then we must overwrite it there and inherit it from there. Right? Okay, where did I get that again? I'm going to go back up, go back down, go back up, go back down. If you have a deep inheritance hierarchy, what are you doing all the time? You're bobbing your head up and down, looking at documentation. That's called the yo-yo problem. Right? So that was the diamond problem. This is the yo-yo problem. Right? The deep hierarchy, inheritance hierarchies are bad. Right? It forces you to look up and down at various documentation to see when and where behavior was introduced or overridden or etc. Right? You're always looking up and down like you're watching a yo-yo. Somebody's going we all know what a yo-yo is, right? The toy that goes up and down, right? And you're watching the yo-yo, you're always bobbing your head up and down, right? That's the yo-yo problem. You don't want a deep inheritance. You want your inheritance as shallow as possible. Now, whether or not you consider this deep, it's not. It's only 4 classes deep, right? Because everything up here is just a interface. You're not locking yourself into that hierarchy. But if they had introduced another layer, another layer, another layer, another layer, right? Then by the time you get to 5, 6, 7, 8 layers, right, you're looking up and down, right? That's a little bit too abstract, right? You're probably doing something wrong, right? Do you really need that or not? Rethink your design. But that leads to the yo-yo problem. The other anti-pattern that I'll mention here, I don't know if we'll get to it here. Yeah, we'll get to it. We've got 3 minutes, is the rectangle problem. So consider a shape, a rectangle, and a square. Rectangle, there we go. Tell me the relationship between those 3 things. A rectangle and a square are shapes, that should be clear. But what about a square and a rectangle? Is a rectangle a square? Nope. But is a square a rectangle? Yeah. A mathematician would say, hey, great, let's go ahead and do that. I don't have it here. Let's go over here then. Where's my rectangle? They're all right here, so close all of these. I don't want any of them. Come on. Oh, by the way, if you get annoyed by that, go ahead and just click off of this thing right here, and it will not follow back and forth. For example, if I open up rectangle over here, right, and then I open up shape and square, right, whatever you're focused on over here will be highlighted over here. But with that shut off, it doesn't do that. So usually I want this on because I'm not always diving into the JDK. And so that if you change your focus square, it automatically changes over here. Right? So that you know, if you've got 2 classes named square and square, you know which one you're referring to based on the focus over here. Right? Anyway, I've got a shape, right, that has a get area method and a set width method. Up here in the rectangle, I've got extends shape, and it's got a width and a height. But what's the problem with a square? Does a square have a width and a height? Yeah, but they're the same. So if I create a square here, and it's going to be a 10 by 10 square, and then I set its height to 5, is that a square anymore? 5 by 10? Nope. what is it? It's a 50 square foot rectangle now, right? But guess what? It's still an instance of a square. Let's run this. Even though it's 5 by 10, S is still a square. Does that sound right? Nope. Sometimes this is called the shape, circle, and ellipse problem, but I find, you know, rectangles and squares to be much more concrete of an idea, so I go with that example instead. If you lock yourself into a hierarchy that doesn't make sense, right, and you have mutable functions that change a square into a rectangle, your hierarchy is probably wrong, right? And there are ways around that, but the ways around that are basically bending over backwards and fighting against your hierarchy. We'll look at it in more detail on Wednesday, but the solution is don't lock yourself into these hierarchies, right? A square is sometimes a rectangle, but it's not always, right? A rectangle is sometimes a square, but not always, right? And if you find yourself saying these things, it is a something, but not always, then that's probably not a hierarchy that you want to make, right? All right. I'll see you on Wednesday then.